Let us look at question number 51 now. The following figure shows the effect of pressure on the compressibility factor Z of a gas at constant temperature. Okay, so on the y-axis we have the graph of Z, and on the x-axis we have the graph of P. Consider the following statements. S1, curve AQRT is true for gases like NH3. So if you look at the graph, the curve AQRT is this graph. And students, we know that this is the graph for the real gases like ammonia, which have both the factors A and B as significant. So S1 is correct. If you look at S2 now, the curve AC represents an ideal gas. In the plot, the curve AC represents a straight line which is parallel to the pressure axis and has a value of Z equal to 1. This statement is also correct, students. If you look at the third statement now, for the curve AQ, PVM equal to RT minus A by VM. Okay. So if you look at AQ, the examiner talks about the low pressure region. If you try and solve this condition, so we have P plus A by VM square into VM minus B equal to RT. So in the very low pressure region, the value of VM will be much greater than the value of B. So we can neglect the value of B in comparison to VM. So we are going to have P plus A by VM square into VM equal to RT. So on simplification, we have PVM plus A by VM is equal to RT. And on simplification, we have PVM equal to RT minus A by VM. Okay. So students, the third statement is also correct. If you look at the fourth statement now, curve AB is true for gases like helium. This statement is also correct, students. If you look at the curve AB, the curve AB represents a case in which the value of A is approximately 0. So we know that in the noble gases, the value of A is approximately equal to 0. So this graph is also correct. So we have to mark option 4 as the correct answer to our question. Let us look at the next question. Question number 52. 100 ml of 0.1 molar CH3COH, 50 ml of 0.1 molar HCl is mixed with 50 ml of 0.1 molar BaOH whole twice. The pH of the mixture of the solution is, we have been given the value of pKa of CH3COH, which is equal to 4.74. So if we try and figure out the MEQs of the acid and bases given to us, so we have CH3COH, its MEQs will be equal to 100 into 0.1, which is equal to 10. We also have HCl. The MEQs will be given by 50 into 0.1, which is equal to 5. And we have BaOH whole twice. The MEQ will be equal to 50 into 0.1 into 2, as the N factor of BaOH whole twice is equal to 2. This is equal to 10 again. Now we have a mixture of a strong acid HCl and a weak acid CH3COH, and we have a strong base in the system, which is BaOH whole twice. So what is going to happen is, this BaOH whole twice will first neutralize HCl. So HCl will be completely neutralized, and the BaOH whole twice remaining will be equal to 5 MEQs. Now in the system we have 5 MEQ of BaOH whole twice remaining, and we have 10 MEQs of CH3COH. Now this will now react with the weak acid and will lead to the formation of the salt CH3CO minus. If we talk about the MEQ, that will be equal to 5, and CH3COH will be left in the system. So the MEQ of CH3COH will also be equal to 5. Now in the system we have a solution where the concentration of CH3COH and the concentration of CH3CO minus as equal. So if we talk about the pH will be given by pKa plus log of salt by acid, and the concentration of both salt as well as acid are equal. So this term will be equal to 0, and pH shall be equal to pKa. So the pH of the system will come out to be equal to 4.74, and we have to select option 3 as the correct answer to our question. Let us look at the next question now. Question number 53. The E0 M3 plus to M2 positive value for Cr, Mn, Fe and Co are these respectively. For which one of these metals the change in oxidation state from +2 to +3 is the easiest? So the examiner is interested in the oxidation of M plus 2 to M plus 3. So the values given to us are the reduction potentials. So if we talk about the oxidation potentials, this value will just have to be multiplied by a negative sign. So it will be equal to E0 M3 plus to M2 plus. And we can see that the oxidation potential of only Cr from +2 to +3 will come out to be positive. So we have to select the fourth option as the correct answer to our question. Let us look at the next question now. Question number 54. T1/4 can be taken as the time taken for the concentration of the reactant to drop to 3/4 of its initial value. If the rate constant of the first order reaction is K, then T1/4 can be written as. So students, it is given to us that after T1/4, the concentration of A, let us call it as AT, it comes out to be equal to 3/4 of the initial concentration. We can call it as A0. Now, if we try and write the expression for the first order reaction, we have KT is equal to ln of A0 by AT. Now, putting the values, we have K into T1/4 is equal to ln of A0 upon 3/4 A0. So this will give us a value of K T1/4 equal to ln of 4/3. The value of ln4 and ln3 are given to us. It shall be equal to 1.38 minus 1.09. So the value of K T1/4 shall be equal to 0.29. And the value of T1/4 will come out to be equal to 0.29 upon K. So students, we have to select the second statement as the correct answer to our question. Let us look at the next question. Question number 55. Silver crystallizes in the cubic lattice. The density of the unit cell is found to be 10.7 gram per centimeter cube. If the length of the unit cell is 0.406 nanometers, the number of atoms per unit cell is, we have been given the molar mass of Ag, which is equal to 108 gram per mole. So students, if we talk about the density is given by Z into M0 upon Na upon A cube. Now, the density is given in gram per centimeter cube. So we have to put this A cube also in centimeter cube. So the Z value is unknown to us. The value of M0 is 108. The value of Na we know. We can use it as 6 into 10 to the power 23. The value of A is given to us, which is equal to 0.406 nanometers. This can be written as 4.06 into 10 to the power minus 10 meters. It can be written as 4.06 into 10 to the power minus 8 centimeters. So this is the value of A which we have to put in the expression. So putting the values, we have D, which was 10.7, is equal to Z into 108 upon 6 into 10 to the power 23 into 4.06 into 10 to the power minus 8 whole cube. So in solving this expression for the value of Z, we have Z equal to 4. Students, the number of silver atoms per unit cell is equal to 4, which is given correctly in option 4. Let us look at the next question.